Next section that we'll look at is titled Pascal's triangle. Pascal's triangle is a definition or table that we'll use to solve problems in the next section. To start off Pascal's triangle, we'll start with the single number 1, and underneath of that we'll put 2 more 1s. This 1 is considered the first row, these 2 1s are considered the second row, and we'll continue down and we'll do 9 total rows for Pascal's triangle. To get the third row, what we'll do is take the 2 numbers above, 1 and 1, add those together, which will get us 2 for the third row. The outside numbers will be 1s. So our first row would be 1, our second row would be 1 and 1, our third row would be 1, 2 and 1. For the next row again, we take 2 numbers above, 1 and 2, add that, and it goes in between the 2 numbers for the next row. We also have 2 and 1 over here. We can add those to make a 3. And to make the triangle shape, always put a single 1 on each side. And again, now we have 4 rows. We will continue down until we have 9 rows. 1 plus 3 would be 4. 3 plus 3 would be 6. 3 plus 1 would be 4. And the single 1s on the outside to continue the triangle shape. 1 plus 4 would be 5. 4 plus 6 would be 10. 6 plus 4 would be 10. 5 and the 2 1s. The next row would be 6, 15, 20, 15, 6, and 1 on both sides. Next row would be 7, 21, 35, 35, 21, 7, and 2 1s. This last row that we did, that would be row 1, 2, 3, 4, 5, 6, 7, 8, and we'll continue on to do 1 more. That would be 8, 28, 56, 70, 56, 28, and 8, with 2 1s on each side. This would be Pascal's triangle for 9 rows. You could continue on the triangle. I'll put dot 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 because you can do as many rows as you need to solve different problems. Couple patterns on Pascal's triangle. Each row increases by 1 number. The first row has 1 number, second row 2 numbers, third row 3 numbers, fourth row 4 numbers. So the 9th row would have 9 numbers. Also, the triangle is perfectly symmetrical. Whichever number you have on one side, you have the same number on the other side. Section we'll use Pascal's triangle for is titled Using Pascal's Triangle. The definition for this one is we will use row exponent plus 1. So in these questions, whatever the exponent is, we'll add 1 to that, and that's the row that we'll use for Pascal's triangle. First question, and only question for the section, is expand x plus y to the 7th power. To actually solve this algebraically, x plus y, you'd have to write 7 parentheses with x plus y, go through and FOIL each one out until you come up with the polynomial for the answer. The shortcut method is we can use Pascal's triangle, and we'll use row exponent plus 1, the exponent 7, so we'll be using row 8. Looking back at Pascal's triangle, row 8, if we write just the numbers down with commas, it would be 1, 7, 21, 35, 35, 21, 7, and 1. To get the answer for the expansion of x plus y to the 7th power, we'll take the first number, which is 1, followed by the first variable, which is x. The exponent will be the exponent originally in the question, which is x to the 7th, followed by y. The second variable will always start with a 0 exponent. And this will be our first term in the sequence, 1, x to the 7th, y to the 0. And then plus our second term will be the second coefficient or second number, which is 7. The exponent on the x will decrease by 1, x to the 6, while the exponent on the y will increase by 1, y to the 1st. Plus the third term, we'll use the third number, 21. And again, we'll take x, decrease by 1, which would be 5, and the y exponent increases by 1, which will be 2. We will continue this pattern for all the numbers in row 8. After 21, we'll have 35. X will decrease by 1, x to the 4th. Y increases by 1, y to the 3rd. The next number, 35 again. X will decrease by 1, and y will increase by 1. Plus 21, x squared, y to the 5th, plus 7, x to the 1st, y to the 6th, and our last term, plus 1, x to the 0, y to the 7th. All these terms will be our final answer for the expansion of x plus y to the 7th power. Couple patterns about this. Again, the numbers are symmetrical. We'll have 7s and 7s, 21s and 21s from the Pascals triangle. Also, if you look at every exponent, every term, they all add up to 7. And you should begin with the exponent 0, and you should also end with an exponent 0. The 0 exponents we can cross off and ignore, because y to the 0 and x to the 0 is equal to 1. And also, if you wanted to, you could take off the 1 coefficients and just have x to the 7th and y to the 7th. Title of the last section today is Find a Particular Term. The equation for this section is combination C n comma r times a to the exponent of n minus r times b to the exponent of r. Combinations we did in the previous chapter, the probability chapter. The two variables on this one, n, is equal to the exponent, which will be given in the problem, and r is the term number minus 1. So whatever the term number is, take away from 1 from that, and that's what r would be. The combination formula that we did in chapter 12 is n factorial divided by n minus r factorial divided by r factorial. A and b will be the variables given in the equation. The first problem for the section, find the fifth term of the quantity x plus y to the exponent of 10. What we can do for this problem, instead of expanding this out using Pascal's triangle and finding the fifth term listed, we can use the rows and the other numbers. For this question we have combination n comma r. N again is the exponent in the question, which would be 10. R is the term number. We're looking for the fifth term, but term number minus 1, which would be 4. So we'll have combination 10 comma 4. And we'll multiply. Instead of a, we'll use the first variable, which is x, to the n minus r power, which would be 10 minus 4. And instead of b, we'll use the second variable y to the r power, which would be 4. Solving this, combination 10 comma 4 would be 10 factorial divided by 10 minus 4 factorial, which would be 6 factorial. Also divided by r, which is another 4 factorial. And we'll have x to the 6th power and y to the 4th power. Multiplying out the factorials, 10 factorial is 10 times 9 times 8, all the way down to 1. And 6 factorial is 6 times 5, down to 1. And 4 factorial is 4 times 3 times 2 times 1. Solving this, the 6 through 1 we can cancel in the numerator and denominator. We can also cancel the 8. 4 times 2 would be 8, and that would cancel the 8. And the 3 we can divide into the 9, so the numerator will be left with 10 times 3 times 7, which would be 210. Bringing our exponents down, x to the 6th, y to the 4th, we would have our answer of the fifth term of the expansion x plus y to the 10th power. The fifth term would be 210, x to the 6th, y to the 4th. Second question we'll look at. Find the fourth term of x minus 2 to the exponent of 7. And again we'll have combination n, which is the exponent, in this case is 7, and r is the term number 4 minus 1, which would be 3. And instead of a from the equation, we'll use x. N minus r, which would be 7 minus 3. And instead of b, we'll use the number 2. Has a negative sign, so we'll use a negative 2 to the r exponent, which would be 3. Multiplying out, 7 combination 3 would be 7 factorial divided by 7 minus 3, which is 4 factorial, and 3 factorial. X to the 4th, and negative 2 to the 3rd would be negative 8. 7 factorial, 7 times 6 times 5, all the way down to 1. And 4 factorial, and 3 factorial. 4, 3, 2, 1 we can cancel. And also 3 times 2 would be 6, so the 3, 2, and 6 would cancel. We'll be left with 7 times 5, which is 35. We have x to the 4th, and we also have negative 8. Since we have a number as our last term, and we have 35, we can combine those, and that would be negative 280, x to the 4th. So the fourth term of the sequence, if we use Pascal's triangle to write out all the terms, the fourth term would be negative 280 x to the fourth. Title of the first section is Graphing Parabolas. First equation is y equals 2, open parentheses, x minus 3 squared plus 4. This equation is in standard form from the previous definition, where we have a, h, and k. First step is to find the vertex. For the vertex, the x value would be inside the parentheses next to the x. The minus sign is already part of the standard form, so the x value would just be 3. And the y value would be k, the number outside, which should be 4. So the vertex would be 3, 4. For the direction, would either be up or down, and we look at the a value, which is the number in front of the parentheses. If this number is positive, then the direction of the parabola would be up. And the last part is the distance of foci and directrix. And the equation is 1 over 4a, which would be 1 over 4 times the number in front of the parentheses, which would be 1 over 8. From here, after we have the vertex, the direction, and the distance of the foci and directrix, we can draw the graph to graph the parabola. The vertex would be at 3, 4. The direction would go up, so we'll sketch a parabola going through the vertex, pointing up. For the foci and directrix, the foci is a point inside the parabola. 1/8 means from the vertex we'll go up the fraction 1/8 and put a single point. For the directrix, it's a dashed line underneath the parabola or outside. And again, this distance would be 1/8 down. And we'll draw a dashed line 1/8 down from the parabola. The definition of the foci and directrix is any point on the parabola is the same distance from the foci as it is from the directrix. And that would be the graph for the equation. Second question and last question for this section. X equals 1/2 y squared. This equation is also in standard form. If you wanted to, you can put parentheses around the y value. And there's no number at the end, but you can put a +0 for the value at the end. The x and the y are flipped for this one, which we'll see in just a minute. That'll change the direction of the parabola. First part's to find the vertex. The vertex, the x value, is normally inside the parentheses. but since the x and y switched, the x value would be the number outside the parentheses, which would be 0. And the y value, again, standard form would be the number at the end, but since x and y switched, the y value would be the number inside the parentheses. If there's no number there, it would be a 0. Find the direction. Normally, again, parabolas either go up or down. Since the x and y values are switched, now the parabolas will either open to the right or open to the left. If a is a positive number, it'll go in the positive direction, which would be to the right. If it was a negative number, then the direction would go to the left. And the distance of the foci and directrix. Would be 1 over 4a. A again is the number outside the parentheses, which would be 1/2. Half of 4 would be 2, so the distance would be 1/2. To graph this, we can draw the xy axis. The vertex would be in the middle at 0, 0. The direction goes to the right, so instead of either going up or down, the parabola would open to the right. And the foci and directrix, again, the foci would be a point inside the parabola, and a directrix would be a dashed line outside the parabola. If the distance is 1/2, we'll have a point that's 1/2 units inside the parabola, and the directrix will be outside 1/2. In this case, the directrix goes up and down. And again, the definition of the foci and directrix, if you take any point on the parabola, any point is the same distance from the foci as it is from the directrix. Title of next section and last section today is graphing circles. First equation, in parentheses, x minus 3 squared plus second parentheses, y minus 1 squared equals 25. This is in standard form for circles, where you have x and y on the same side, both to the second power, and it's equal to a number. The center for the circle, the x value would be the opposite of the number in the x parentheses, which would be 3, and the y value would be opposite of the y number, which would be positive 1. And the radius for the circle, the number it's equal to, you take the square root of, so the radius would be 5. To graph a circle, you can draw the xy axis. We'll do the center first, which is at 3, 1. The radius of 5 means that's 5 in every direction. To graph a circle, from the center we can go up 5 spots. And also from the center we can go down 5 spots. And again, from the center, we can go to the right 5 spots. And last part from the center, we can go to the left 5 spots. So from the center, you go in every direction 5 spots. Once you have those 4 points, you can connect them to make a circle shape. And that would be the graph of the equation. Next equation and last equation for the problem is x plus 2 to the second power plus y squared equals 9. Again, this is in standard form. We have x and y squared on the same side and equals a number. If you want to, you could put parentheses around the y value. The center. The x value again will be the opposite of the number in the x parentheses, which would be -2. And if there's no number next to y, the y value would be 0. The radius, again, is the number it's equal to, but you take the square root of that number, so the radius would be 3. To graph a circle again, draw the xy axis. We'll graph the center first at -2, 0. And from the center, we'll go up, down, left, and right. The radius is 3. So we'll go up 3 spots, down 3 spots, to the right 3 spots, and to the left 3 spots. Once you have those 4 points, you can connect them to make a circle. And that would be the graph of the equation. Title of the first section is Graph and Ellipse. First equation, inside parentheses, x minus 3 squared divided by 16 plus inside parentheses y plus 2 squared divided by 9 equals 1. This is in standard form for an ellipse, where you have x and y on the same side, both squared, each one divided by a number, and it has to be equal to 1. To find the center of the ellipse, the x value again, we'll take the opposite of that number, which would be 3. And the y value would be -2. Instead of a radius, we'll have a major and minor axis. The major will be the bigger number underneath the fraction, which would be 16. But just like the radius from the circle, we'll take the square root, which would be 4. After the 4, since the 16's underneath the x on the fraction, we'll put an x. So this will be 4 units in the x direction. For the minor axis, we'll take the smaller number underneath the fraction, which would be 9. And again, take